In this project, first we import the necessary libraries. This is the cell of important libraries. Like we have first import the libraries like numpy, np, h5py, pandas, matplot.pplot, and matplotlab.gitspace. Numpy is for handling the array and numerical computation, and the h5py, this is used for the reading and writing the all data sets, and pandas uses for the handling and analyzing the data set, and matplot lab dot pyplot, this is used for the plotting and uh, visualizing the data set, and the grid space is also used for the creating complex subplot layouts in plots. That's it. And cv2 is used for the image processing and computer vision task. This is help to plot the all data set that is used as the form of image like this. In this cell, we import the library like TensorFlow, Keras, NumPy, Matplot, CV2OS, TQDM, the TensorFlow. This is used for the TensorFlow library, which includes support for the low-level operations. And Keras, this is also used for the interface for the building and training deep learning models. This is help during the plotting the all dimensions of the diagram or the images. And Keras layers, this is help during the plotting of the images. This provides the layer like to for defining and deep learning architecture, useful for the implementing the GAN model layers. In this cell, we take the data set and we import the data set. Our data set in the zip file. So for this, first we unzip that data set. So for this, we use this command for unzipping this data set. df -h. This command used for the checking the space in our drive, how much space is remaining, and import drive dot mount. This command used for the checking the checking the connectivity between our system and virtual machine. And in this cell, we set up the image for a GN model that colorize black and white images. Here we have defined the sorted alphanumeric. This is used for the ensuring that all the data set are in the proper order for the processing. Here we have uses size as a variable. This meaning all the data sets of the images are in the same size like 256 or 512, etc. This is the in this we are using looping function. This looping function checking all the images are in the given format or not. If the images are not in the given format, then this converted into resized and normalized to all the images and then converted into array format. This cell using for the training and testing all the data set that we are using in this project. In this cell, image color holds the first batch of the color images from the color data sets, and example gray, that's for the first batch of the grayscale images from the gray data set. In this cell, this plot image function is set up to display a pair of color and grayscale image side by side, and this loop is a function loop display for pair of image unless specified otherwise. Display setup like each iteration it creates a new figure with figure size that is given 10 by 10, and this PLT subplot 1 to 1 is used for the setup the left subplot of the color image, and this subplot 1 to 2 is used for the right subplot of the grayscale image. In this cell we are using downsample and upsample. This is commonly used in the CNN technique for the image generation and processing the task. This downsample and upsample are used in the GAN technique also for the breaking the function. This downsample reduce the image dimensions, which is useful in the encoder part of the networks, and this upsampling increases the dimension of the typically for the decoder part, that is reconstruct or generate the images according to the dataset which we given in this cell. After that we are using generator function. This constructs the unit style architecture for the image to image task like image colorization. In this we are using model such like that down stack, up stack, then skipping, up scaling, up sampling, and this generator function returns to a garage model for input and to x, where x is the final generated images. And this generator also provides a flexible architecture for tasks involving image generation using the GN based libraries. After that, we define the discriminator function. This function is used based on the patch-gen discriminator. Patch patch-gen discriminator. This is the translation of the image to image that breaks down all the images into their realistic or fake images that defines based on the garage layer input and their zero pad, and also the each value of the correspondence to the realness score for each patch. The patch gen discriminator judge realistic at the patch level of the images. This patch gen is mainly used in the two function, in the two type of algorithm, peaks to peaks and cycle gen. And our project is also based on the GN technique, so we are using this discriminator function that is based on the patch gen. After that, in this cell, we are using the generator summary as a function that display all the summary of the generator model that we are using in this project, like layer type, details, output, shape, and this is connected to param. And also we are using generator function like input layer, downsampling layer, upsampling, skip connection. Based on this generator function, the overview we get depends on the model what we want, and this also helps ensure the architecture what we are given in the input form that we get in the output. After the generator cell we have to also check the discriminator, and in this cell we are checking using the discriminator function. In this function we get the detailed overview of the discriminator of the module. After executing this discriminator function, we get this model based on the input data what we have given in the input form that we get in the model form like in the output form, layer, output, shape, param, and connected to. These all are the data set. This total param defines the total number of the trainable parameters in the model, and these trainable params define the total number of the parameters that will be updated during the training, and these non-trainable params that define the parameters that do not get updated. After that, we are using the gen loss and disk loss function. This is totally used for the initializing the list to store the generator and the discriminator that is used before training the both data set, and this is commonly used for the gen technique. That's a performance of the both model over times. After implementation of the loss function for the generator and the discriminator, we are using the loss function breakdown. That is the loss function, generator loss, and discriminator loss. That's are totally define the output within our training loop after generating image from the generator and getting output from the discriminator. In this cell, we have defined the train step. This train step function is a crucial part of our GN implementation. This effectively handling the training of both models. And this function executes a single training iteration for a GN technique by calculating the generator's output from the input images, computing the losses for both the generator and discriminator, and also based on their output, calculating the gradients for each model and updating their weights using the Adam optimizers. After that, we define the fit functions. This is essential for the managing the training process of the machine learning model. Basically, in the GN technique, this fit functions train as a GN for a specified number of epochs by iterating over the uh, all training all training uh, data set, and that invoking the train step function for each batch while measuring the printing the times taken for the each spoke, and also the logic for the training the model, improving the code organization performance tracking, and also maintenance the which are crucial in machine learning workflow. That's also this one. The previous code, that is training a step loss function etc., that's established the groundwork for building a GN and the training to learn the mapping from the grayscale image to color images. And this generate image function is to crucial component that complements the previous GN techniques, and also the code providing a way to visualize the results of the trained generator model. It also takes some input images and their corresponding ground truth color image, generate prediction using the trained generator, and display all the three images side by side for easy comparison. This visualization enable to assess the generator performance after training the model in the transforming grayscale image into color, ground truth, predicted image, and also identify the area for the improvement for the future. This line of code initiates the training of the GN model using the zip dataset of grayscale and color image for two epochs, and the previously defined fit function to manage the training process, and potentially store training matrices for the further analysis that is used in the future. Here we are using Seaborn and Matplot libraries to visualize the loss value of the generator and the discriminator during the training of our GN. The training losses of the generator and the discriminator in our GN model that offer the training iteration using a line graph, this line graph, and format to facilitate comparison. The usage of Seaborn for styling enhances the plot of this graph, and while the inclusion of the title and label that improves the clarity of the interpretation of the results, and this also visualize the crucial monitoring that training process and diagnose the model performance over the time. Better model. by comparing the input grayscale image, the ground truth color image, and the predicted color image side by side by easy evaluation. And this depth generate image function take in the models as test input and tar this. So this generator model creates a predictive based on the test input, and this and then this plot figure. This is the setup with the large size to comparatively display three images: input, target, and prediction side by side. And then after this display list test input, this store the first item of the test input tab, and this represents a single input target prediction triplet for display, and a title. This title holds for the images providing context each subplot. And now after this looping iterate over the display list to plot each images, and this plot subplot 1 3 I plus 1 setup. This is the layout with one row and three columns, and this plot titles. This is the label of the title from the title, and this is the print. This is the output of the shape that is given as the test input to 0, and this also verify the dimensions are correct or not. And this plot image displaying the image, and this plot axis of remove the axis levels from the cleaner view. And finally this plot showing the plot area. And now this is the final example. We have taken the example as a given data set, 11 example from the zip data set of the grayscale and color images, and it calls generate image to visualize the generator's performance. Now this is the final output we get through the zip data set. This is the input image, this is the ground truth, and this is the predicted image.